So, I don't like looking at myself. So, what do you think this is the power of 2 of?
3.
2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7. For subnetting, this is extremely important. So to get a good grasp of it, you're going to need to know this. This isn't like, oh, chapter 1, I can mess with it and then not have to deal with it again. You got to know this pretty solidly for subnetting.
I already know the answer.
Oh, hang on. Wait, hang on. What is 2 to the 0 equal? What is 2 to the 1 equal?
2, 4, 8, 16, 30,
128.
Okay. Everyone's with me so far?
Yeah.
Okay. If I have a 1 here, what that signifies is this is going to be 1 times this number equals. So what's 1 times 1?
1.
0 means 0 times this number, which equals.
0.
So what's this going to be?
0.
What's this going to be?
0.
What would this be?
16.
16. What's this?
32.
What's this?
0.
And what's this?
128.
128. So then what you do is you add all of these together. And that equals 128 plus 32 is 160, plus 16 is 176, plus 1 is 177. So 177 in binary is 10110001.
I thought we were doing 100.
We will. I wanted to.
We were.
We were, but I wasn't. Edward wanted to show that one off, so he wanted to. So,
I think I know the
did you use a binary calculator?
No, I didn't.
0, 0, 0, 1, 0.
I think you just need
Yeah.
Do it.
this one. Right?
64 plus 32 is what? 96 plus
That's
4?
right.
Yep.
Is there another way though?
Nope.
No? It's only one way to
There's only
express
one way to-
number.
In binary,
But
yeah.
does it do every single number from one?
So an 8-bit number can do every number from 0 to 255. If you go 2 to the 8, that equals 256. Right? I can represent every number from 0 to 2 to the 8 minus 1. Right? Because if this were. So if I did 1, 1, 1, 1, 1, that's 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, which equals 255. Does that make sense?
Why is it minus 1?
Because if I wanted to write 256 in binary, I would need a 9-digit or 9-bit integer, 8-bit number. A 9-bit number, and 256 would be 1 and all zeros. Because this number would be 2 to the 8, and that's 256. It's typically 8-bit. Does that make sense?
I just don't know why it's minus 1. 2 to the 8 is minus 1.
Well, I just explained it.
Can
You
do another
didn't
learn
explain it.
example?
Yeah, I'll do another one. No, if I didn't explain it well enough, tell me that and I'll explain it again.
I don't think you explained it well.
Okay,
Because you said
so if I want to
just
write
add
0
one bit.
with an 8-bit digit, 8-bit integer, I want to write 0. What's my binary equivalent of 0? All zeros, right?
Yeah.
Edward, does that make sense? If I want to write 0,
Oh yeah, all 0.
I would do 0, 0, 0, 0, 0, 0, 0.
Yeah.
That equals 0.
Yeah.
Okay. If I want to write 255, I would do 1, 1, 1, 1, 1, 1, 1, 1. With 8 bits, this is the biggest number I can write, is 255.
Okay.
Which equals 2 to the 8 minus 1. If I added a 9th digit and I wanted to write 256, it would be 1, 0, 0, 0, 0, 0, 0, 0, 0. So with 8-bit, So if I'm doing a 6-bit number, the highest number I can write in 6 bits is 2 to the 6 minus 1, which is 63. But I can still write, now this is where it gets kind of confusing. I can still write 64 numbers because you have to include 0 to 63,
Yeah.
which is 64 individual numbers. Does that make sense? Right, in computing, you almost always count 0 as a starting point or within your set of numbers. I have a couple of, looks like there's a couple confusing looks. Any questions before I do a couple more examples?
Can you tell these guys to stop laughing at me?
Jared, please stop laughing.
Smiling.
Especially Jared.
I can't.
I don't know, I feel bullied.
What?
Yep. I feel so bullied.
Don't forget, this is being recorded. Let me double check that it's being recorded.
Always record. Alright.
And I am gonna put it on YouTube, so if you guys have any questions.
What?
Be careful. Mr. Brooke is gonna talk with you.
Yes,
So refreshment, this is called binary?
this is binary, yes.
Oh, can you tell us the trinary?
Trinary?
No, no. They have base 3, but it's not really used. You have binary and hexadecimal.
Oh yeah.
Hexadecimal is
10.
base 16.
Oh, 16.
This seems
What
like
is
a lot of math.
what is base 10? Decimal?
I don't know. I've never heard of base 10 is base 10 is decimal. That's what we use.
Oh yeah, decimal. Yeah. Oh yeah, you're right.
Yeah. So the only math if you can type in 16 raised to the 3 minus a number, that's all you really need. And if you can go 1, 2, 8, 4 minus 3, 6, 2, like that's the only math you need.
Wait, hold on. I think
I'm making up numbers to prove a point. I'm not actually coming up
for
with
this
real
one.
numbers.
So under each one, it's whatever number you're trying to get raised to that power, or what? Like
No, so this in binary, this spot in binary out of 8 digits is represented by 2 to the 0, which equals 1. So if you have a 1 here, you're going to add 1 to all of these other numbers to get binary, to get your number.
so then it's just 1, 1, 1, 1, 1.
It depends on the number. So let's start here. Let's start with the Okay, so if I want to write in an 8-bit number and I want to write the number 1 in binary, what is it?
8-bit number 1.
0.
0, 0, 0, 0, 0, 0, 0. We're just going to count up using binary, right? Because right now, 1 times 1 is 1. So 1 equals 0, 2, 3, 4, 5, 6, 7, 1. Do you understand that?
Yeah.
Okay, let's go to 2. One way, so if I have 2, is 2 bigger or smaller than 128?
It's smaller.
Is it smaller than 64?
Smaller.
Small. So it's smaller up until here, right? 2 subtracted from 2 is what?
0.
So this is 1, 0. Does that make sense?
Kind of, but I don't understand why you did that.
Why I did what?
Why you subtracted 2 from 2.
So it's to figure out where I have to put a power, right? So if I want to do 1, 1 is smaller than all of these, right? Except for this last one. And I want to get, if I want to write the number 94 in binary, I want to subtract numbers from this until it equals 0. Right? So when I'm starting with 1, I want to subtract these numbers from 1 until I get 0. The only way I do that is right here, is in this spot. Same thing with 2. I want to subtract numbers, so I got 2. Oh, I'm sorry. 1, 0. Now, if I want to write 3, 3 is smaller than all of these, right? Until 4. So now I have 3 here. So I have 3 minus 2 is 1. And now I have 1 that I want to write here. So then I write 1. So 3 is 1, 2, 3, 4.
Okay. Kind of.
So if I want to do 4 minus, which one of these gets us close to 0 if we subtract from 4?
4.
So 4 minus 4 is 0. So 4 is right here. So 4 is 0, 0, 0, 0, 0, 1. And then I have 0, 0.
Wait, there's
Zero.
a 0 there.
Oh, my bad.
Okay.
Right? So let's do a slightly bigger number. Someone shout out a random number from 0 to 255.
32.
32.
30.
Oh no. What is that? Double your age?
That is my dude.
All right, so we're going to do 32.
32 is right there. That's too easy. Let's do 33.
Well, hey, let's start with 32. Let's start with 32. So, 32, I start right here, and I want to subtract a number from here to get it down to 0.
Oh, it's 0.
Can I subtract 128
No.
and get 0?
No.
What about 64?
No.
No? So these are going to be zeros. What about,
Yes.
and I'm already at 0, right? So I'm going to go 0, 0, 0, 0, 0. So 32 in binary is 0, 0, 1, 0, 0, 0, 0, 0.
0.
Don't do that to me, man. Whoever did that, that was funny, but don't do
Jeez,
it.
Sam.
That was funny.
Oh my goodness.
So is the 2 always the same? The 2 underneath, like 2 to the second?
Yes,
You're looking big.
right? So, it's because I ate a lot for lunch, okay?
I wasn't saying fat. I was saying muscular.
Oh, okay. That's why I wear loose shirts, man. All right, so someone else come up with a,
5.
no.
225.
225, that's a good one. That's a really good one.
138.
225.
Is it whoa.
No, it's not 1.
Wait, what?
225, not 255.
Oh, 255.
So, is 255 bigger than 128? Can I subtract?
Yes.
128?
Yes.
What? Yeah, 128. So I'm gonna do a 1 here. What does this equal? 97?
97, yeah.
Yeah, 97.
That's right, I got it right.
Can I subtract 64 from 97?
Yes.
Minus 64,
33.
33. Can I subtract 32
Yes. 1.
minus 32, which gives us 1? Is 6? Can I subtract 0, 0, 0, 0,
1.
1? So 225 in binary is 1, 1, 1, 0, 0, 0, 0, 1.
Now let's do 173.
173.
That way, so.
Wow. Very light.
That's what you weigh?
Yeah.
That's very light.
You're only 173 pounds.
That's what I'm saying.
That's
need
like
to gain
Really?
some weight, bud.
You're 173?
He needs to gain some weight.
How much do you think I weigh?
165.
I don't know why we
190.
just got the same number.
190.
My scale is broken, but I'm about 178, 180.
You guys are small.
I'm the same.
We can beat.
Whatever. Okay, let's get. Okay, we're getting off track. We're getting off track. Come on, come on. So 173 is 173 bigger than 128?
Yes.
I'm gonna subtract 128. What does this give me?
45.
Is it 45?
Yeah.
Yeah. Is 45 bigger than 64?
No.
Okay, I'm gonna put a 0 there. Is 45 bigger than 32?
Yes.
So I'm gonna put a 1 there.
13.
Minus 32. Okay, awesome. 13. Is 13 bigger than 16? No. So we're gonna put a 0. Is 13 bigger than 8?
Yes.
All right. So I'm gonna put a 1 here. Minus 8. That gives me 5. Is 5 bigger than 4?
Yes.
I'm gonna put a 1.
0.
5 minus 4 is 1. Is 0. 1. So 173 is 101011101.
Do we have to memorize like 128, 64, 32?
This is really cool.
Yes.
Answer.
You will need to know that, right? If you just want to start with, I know it's 8 numbers and it starts with 0, and if you want to build on your test, 2 to the 0 is 1, 2 to the 1 is 2, and that's fine. As long as, if I give you a number, because on your tests, I'll go what is 124 in binary? And you have to either write it out and prove it to me, or you pick from multiple choice.
Oh. Wait, is there a way to tell what a number is in binary without actually doing all this?
You can tell if it's odd or even, right? So all of these are even numbers, and if you add an even number to an even number, you always get even numbers. Except for this last one, which is equal to 1. So if I give you a number, so if I say, let's go 172, true or false, it equals 1, 0, 1, 4, 5, 6, 7, 8.
False.
Why?
Because there's a 1 on the end, and if you subtract a 1, that makes it an odd number no matter what it is.
Exactly. So if you have a 1 here, you know it's going to be an odd an odd number. Now, could it be 0, 0?
Yes.
It could be 0, 0. Right? That's about instantly without practice. That's the easiest, or whether or not you're right. The easiest way to check whether or not you're right. It's not always going to work, because you could do the decimal for 170 on accident and be off by 2 and still have it end in a 0. But
One is wrong.
what?
That was a false.
I know. I said, could it be?
I know, but it was false. I got it right.
What's 172 in binary right now?
It's right behind you. If you just
That
take the
was
one off the end,
173.
you take the one off the end.
Haha.
Clever.
See? So 172 in binary is 101011100.
Jared, way to work.
I got a round of applause. Look at that.
So does this make sense?
Now it does.
Now it does. So I say all that
Sam, why did you
to explain an IP address of 198.162.0.1. This gets broken down into binary in your computer.
Okay, can we try to do that ourselves and we compare answers? You just have
What time is
binary dot binary
I
dot
only-
binary dot binary, right?
That
8 bits.
you do that in subnetting, right?
We don't have time.
Okay.
So not today.
Are we
Okay.
gonna
How
learn?
do you know how many bits there are?
It's always going to be 8.
Always gonna be 8?
Well, in this class it'll be 8.
Okay.
You do have 32-bit numbers, but that's 2 to the 32 minus 1 numbers you can get.
Okay.
Which, you know how I said you can have 4.2 billion IP addresses? This is why. Because I can have 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 1, 2, 3, 4, 5, 6, 7, 8. So if this is 2 to the 0, 2 to the 1, 2 to the 7, 2, 8, 9, 10, 11, 12, 13, 14, 1, 2, 3, 4, 5.
28, 21.
I'm trying to find that. Genius.
21.
32 bit is
So is this IPv4,
Whatever.
right?
2 to the 30.
That's the one in
Yeah, this is IPv4.
this. And what's
Wait, no, that doesn't make sense.
the other one?
0,
is
1.
IPv6.
This should be 31. Whatever. Stop messing with me, Jared. Right? But can have 2 to the 31, 2 to the 32 minus 1 IPv4 addresses. Yeah, okay. You know what?
I'm sorry. I'm just like real detailed.
All right, fine. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 2, 23, 24, 25, 26, 27, 28, 29, 30. So 30. Fine. Whatever.
Thank you.
You're welcome.
you look so mad.
That's not even the right amount of numbers. Isn't it 31?
What's 8?
Okay.
Because it's 32-bit. So you go to 0 to 31, it's 32 options.
It should be. You guys are throwing me off,
You're
man.
missing a
Yeah, one of
dash.
them has.
One of them has.
I think it's,
1, 2, 3, 4,
That's
5, 6, 7, 8. So that has 8.
that has
1, 2, 3,
Just
4,
subtract
5,
the
6,
numbers
7,
from each
8.
other.
8.
that one doesn't.
Oh, we got it.
There we go. So
That
this
should be 15.
We got it,
Jeez,
guys.
man, you guys.
That should be 15.
16, 17, 18, 19, 20, 21, 22, 23. You guys happy?
Very much so.
Okay. So, I can have 0 to 255 in this section of my IP address. I can have 0 to 255 in this section. I can have 0 to 255 in this section. And I can have 0 to 255 in this section. So if you do 255 times 255 times 255 times 255,
Times.
or I'm sorry, 256 times 256 times 256 times 256, you get like 4.2 billion. Same number, I think, is if you do 2 to the 32 minus 1.
Oh, you are saying how many different combinations there can be.
So I can have 10.0.0.1, I can have 172.43.8.7, that's a Z.
What is this?
Z.
Permutation or combination?
It's permutation.
Because the order matters.
Yeah, so it's a permutation.
Oh, football.
Drum on. Anyway, so do you guys understand IPv4 addressing and how it works with binary?
Yes.
Any questions? Okay. So, with IP addresses, there are, let me make sure I'm not going. So there are certain ranges that they use in your house, right? If you guys go to your house and you do IP config, you're gonna get one of three types of, you're either gonna get 10.0.0.1 all the way to 10. I think it's 255, right? Yeah. 255.255.255. You're gonna get 172.16.0.1 all the way to 172.31.255.255, or you're gonna get 192.168.0.1 all the way to 192.168.255.255. Right? These have been reserved. These are called private IP addresses. These are what, if you check your IP address right now, you guys are going to have 192.116 or 172. You're going to fall within this range. At my house with WoW internet, I fall within this range. And if you have Comcast, you fall within that range. Yeah. Period. The reason that is because outside of this range, those IP addresses are reserved for companies. Companies have bought them. Comcast owns, I don't even remember the numbers. I have a list of IP addresses that we own as a school. It's like 63.64.128.7. As I write a 6. 7. Right? This is owned by the school for whatever purpose Mr. Vishnoff has deemed it. You won't have this IP address at your house. Right? Does that make sense? Technically, I guess you could manually set your IP address to this, but there's really no reason why. Right? Does everyone get the private IP address range versus ones that have been purchased by companies?
Why would a company purchase an IP address?
So at your house, so your computer, so the way your network is set up at your house, here's your computer. Whatever. This.
White Sox tickets. You have the best boss.
It's not my boss, it's a benefactor, I think. But I have plans.
What is
so.
the benefit?
Ooh.
Someone who does good things for people, basically. So right now, my computer is going to have 192.168.0.4 at my house. Guys, pay attention. From here, who here has heard of a modem?
Oh, we read it, but I don't understand it.
Right? This is a modem. It stands for modulator, demodulator. Right? A modem is where the internet comes from outside, goes into your house, and it connects to this via a twisty gray thing for now. We're going to learn the actual name for that. It's an RG8, I think. So that twists into it, and that's your modem. A lot of modems nowadays double as a router, so you don't need to buy separate. But how much time do I got? 2 minutes. So your modem also has an IP address. this IP address has been purchased by, it hasn't, so actually, it has two IP addresses. One is facing your house, which is 192.168.0.1. One facing the internet, which is this right here. Does that make sense? Right, so instead of you having to memorize this number, they have an inward facing IP address for your computer to talk to the modem, and then it has an outward facing IP address so that the internet can talk to the modem. Yes.
Why don't they just do a straight shot?
Straight shot?
Yeah.
Because, wait, straight shot in what way?
Like, why don't you connect 63, whatever, to the computer
Because it's
straight?
different than your whole network. Like,
Because I need to have something here that regulates traffic on my network. If I only ever had one device, I could do that, but we don't. You have 7 phones, you have an Xbox, you got a PlayStation, you got a couple laptops. So you have to have an inward facing IP address for all of your other devices to talk to, and then you only have one outward facing IP address. So when you talk to YouTube, it gets basically gets 2 bits of information. It has the outward facing IP address and the IP address of the thing that's requested it. So that's why when you're at home and you're on YouTube and you're on YouTube, your guys' streams don't get crossed. Right? Don't cross the streams. Anyone get that reference?
Ghostbusters.
There we go. Yeah. This also explains why at your house, why Sam can be at his house, do IP config. He has this IP address. Jared goes to his house, does IP config, and he has the exact same IP address. Well, why isn't what Jared requests from YouTube going to Sam's computer? Is because your modem has a different outward facing IP address. You know, Jared is 0.7 and Sam's is 0.8. So the traffic knows instead of going to Jared's house, I'm going to go to Sam's house. Does that make sense? Now I know we didn't cover
everything.
wireless, but going over this, having a good sense of this will make 1.4 and 1.5 a lot easier. So today, your homework, you know what? If you have any questions on 1.4 and 1.8, reread the chapter and come to class with those questions. I want to answer specifically those questions, and then we're going to hopefully I'll get those routers in the next couple days. So the only homework is to make sure you bring questions that you have on 1.4, and I expect at least one question from every person just because it's confusing. Have a great weekend, guys. I'll see you Monday.
Thank you.
Please
You're welcome.
Mitchell in our office. Mark Geezer.